Rock today. Okay, here we go now. I don't know where these came from, but they're cool. They're going to actually help us with some other identities later. This is the sum and difference formula. Why? They're really easy. So here's sine. Sine is equal to sine of u cosine, oh, excuse me. Okay, do x and y. Cosine v. Now u and v, oops, not Cove. I'm struggling today. This is why I usually do these later. Plus sine v cosine u. Now, that's if it's the plus one. If it was the minus one, guess what the sign's going to be? Minus. Okay? Now let's do the cosine sum and difference. It is cosine u cosine v. Now if it's a plus, it's a minus. And if it's a plus, it's a minus, it's a plus. Does that make sense how the notation's working there? Okay. Sine u, sine v. Ladies and gentlemen, I don't know tangent, so what does that mean to you? Once again, did you guys remember what I told you? If I don't know it, do you have to know it? So therefore, you could put that on a note card. And the reason why I don't know tangent is because what's sine over cosine? Tangent. And most of the time, they're going to say find the cosine of this, find the sine of this, and then find the tangent. So if you already know cosine and you already know sine, why memorize the tangent? Does that make sense to everybody? Exactly. Now it can be simplified, Trevor, and you can look in your book on page 400 if you'd like to look at tangent. Once again, I'm not going to ever show it because I don't care. Yeah. Hi. Yes, you could. Because remember, you're just kind of like this. If you knew sine, and you don't know cosine, I just put like a variable, but you knew tangent. You know what I mean? Good question, Megan. So let's go ahead, and I want us to find the cosine of 75 degrees. So is 75 degrees one of our unit circle angles? No. But are there two angles in my unit circle that add or subtract to become 75? Sure, 30 plus 45, huh? So this is cosine of 30 plus 45 degrees would equal cosine of 30 cosine of 45. Because it's a plus, it is a minus sine of 30. I should put parentheses around it. I didn't do it on the first one. Sine of 45. Okay. How are we doing so far? Pretty easy? Yep. Same sign, yep. That's how I remember it. Sine, same sign. Cosine, different. Okay? So what is the cosine of 30? Do we all know what that is? I know what it is. It's root 3 over 2. What's cosine of 45? minus sine of 30 is a half, and sine of 45 is root 2 over 2. Which is root 6 over 4 minus root 2 over 4, which is root 6 minus root 2 over 4. Was that too hard? We could do that, couldn't we? Any questions there? Pumpkin seeds? I do. Yeah. So this time I give you a formula and I want the exact value of it. Do you guys know what the sine of 65 is? But if you'll notice, this is the difference of sine. Because notice it goes sine u cosine v minus sine v cosine u. So it's using the formula. So could I go backwards to say this is the same thing as sine of 65 minus 5, which is who? And do we know the sine of 60? What is the sine of 60? Any questions there? Okay. Now you remember those formulas that I didn't know, like the cosine of pi halves minus x, which was equal to sine? Okay, we're going to verify that. Let's prove it using our formula. So this would be cosine of pi halves sine of x, correct? Is everybody there with me? Minus, oh, that's wrong, that's wrong. Nope, that's all wrong. Cosine of x, there we go. Plus sine of pi halves sine of x. Okay? Yes, sir. Because it's the difference of cosine. See, that's a difference of two angles. X could be an angle, right? So that's a difference of cosine. So that's why we're using sum and difference today. So therefore, Trevor, what's cosine of pi halves? What's 0 times cosine then? What's sine times pi halves? I mean, not sine times, sine of a pi half, sorry. 1 times sine, sine, and notice we just got sine. Can you understand why I never memorized those formulas? Because I'm going to make you memorize these formulas, right? And if you know how to do these formulas, would you ever have to worry about doing that? No. Does that make sense? Okay. Now, say again, I'm sorry. Okay. This time, I'm going to replace this. Isn't this just an angle? When I see an arc cosine or an inverse cosine, aren't they angles? Correct? So I'm going to just call him U right now because that's the angle. And I'm going to call him V because to me it's just easier to do that. So I want to know the sine of U, the cosine of V, plus the sine of V and the cosine of U. But I need to go ahead and draw triangles because remember, when I see an arc cosine, I can draw, or an arc sine or an arc tangent or arc secant or whatever it might be, I can go ahead and draw a triangle, can't I? Okay, where is cosine 1? Well, that's saying here. Okay, where is that located? I actually know where that's at. Where is the arc cosine of 1? Where does cosine equal 1? 0. So this is actually just 0. So instead of U, I could put 0. Does that make sense to everybody? Yes, no, maybe so. Why did I do that? Because what is arc cosine asking for, Abdi? An angle. What angle gives me a cosine of 1? There you go. Answer your question? Okay. So, notice, now here's V. So I'm going to draw a triangle. Okay, the arc cosine is x over 1. And I'm going to call that V for the angle. Should I do that off the blue and down here? Is it easier to see? So here's V. The cosine of that is x over 1. So therefore, this guy is the square root of 1 minus x squared. Does everybody agree with that? We okay? Okay, what's the sine of 0? 0, right? So this whole side becomes 0. What's the sine of V? Well, let's look. Sine of V. Here, I'm standing at V. What's the sine of it? Square root of 1 minus x squared over 1. So it's just square root of 1 minus x squared, isn't it? A lot of you guys struggled on the last test on this stuff, didn't you? I don't know if you looked at your test, but a lot of you did. So you got to remember that this is just an angle and you can draw stuff, okay? What's the cosine of 0? 1. So our answer is 1 minus x squared. Square root of 1 minus x squared. On this side, what is the sine of 0? There you go. And 0 times anything becomes 0. You with me? Okay. Any questions so far? Should we try another one of those in a way? Okay. There's usually ones, I haven't seen it yet. Okay, here we go. If I know that the sine of U is 5 over 13 and the cosine of V is 3 over 4. This one's in quadrant 4. This one's in quadrant 1. I would like us to find sine of U minus V, cosine of U minus V, and tangent of U minus V. Everybody good? What you doing today? Where are you supposed to be? Religious studies. So here we go, guys. I got to draw triangles because do I know what U is? So therefore, I'm going to draw a triangle. Because once again, anytime I see a trig function, I can draw a triangle, right? Here's U. I know the sine of it is 5 over 13. Good old Pythagorean theorem tells me this guy's 12. Hey! Chris Farley. He was a... Thanks, Sharon. Okay, 3 over 4. What's the other guy? Negative root 7. By doing Pythagorean theorem, right? You guys should know how to do Pythagorean theorem. Okay, is everybody there with me? Does everybody understand what I have? Okay, so remember, this is sine U, cosine of V, plus minus sine V cosine U. Is everybody there with me? Yes, no, maybe so? Alex, you okay? Okay. Who is the sine of U? Well, we already know it. It's right up here. It's already told us, huh? The sine of U is 5/13. Who's the cosine of V? Oh, we already know that. That's nice. 3/4. Yes, no, maybe so. Do we feel good? Minus, who's the sine of V? So then I got to go to my triangle, right? And what is the sine of V? Negative root 7 over 4. What's the cosine of U? 12/13. Is everybody there with me? Which we get 15 minus, a minus makes it a plus, doesn't it? Plus 12 root 7 over 52. Notice I have found the exact value of that difference of angles. Just a lot of plugging and chugging, right? Okay, here we go. Let's do cosine of U minus V, which is cosine of U, cosine of V. Now, because it's a minus, what goes in between it? A plus sign, sine of U, sine of V. Who is the cosine of U? We already know it's 3/4. The cosine of V is 12/13. Plus, the sine of U is 5/13. But the sine of V is times, make sure you have a time so you don't think it's subtraction, negative root 7 over 4. Everybody there? We on it like blue bonnet. Okay, so what does that get us this time? 36 minus 5 root 7 over 52. Okay, was that too hard? We could do that, right? Okay, now I know that tangent is sine over cosine. How are we doing? Are you mocking my handwriting? It's a little bit different up here, okay? That's a lot of things. So isn't that because if I times this guy by his reciprocals, do you guys see how the 52s would cancel out? So therefore I'm at 15 plus 12 root 7 over 36 minus 5 root 7. Are we done? Why am I not done? Do we like square roots in our denominator? Those little sons of biscuits. Okay, so I'm going to have to times by its conjugate. Whew. What's its conjugate? 36 plus. Hey, you two can't do that. I'm just teasing them. They're a married couple that works here, so I have to tease them. How are you? Yes, we are doing sum and difference formulas of trig. Yeah. It does. It's like hubba. I'm sexist to my man, you know. Did a little cat call at it. Because I'm guessing it's not appropriate cat call anymore. That's what I've been told. Oh, nuts and crackers. Thank you, both of you guys, little softies. Hey, I think I'm going to give extra credit for you going to the play. Not you. Because you're in it. Oh, I thought you were. Are you in it? Yeah, you don't get it. I don't give extra credit for people that go to football games if they're in the football game. That doesn't make sense. Are you in to play every day? So it's not like double casted. All right, I'll give it to you. No, only once. Huh? No, hell no. We're just running in circles. My kids do that around me all the time. Do I? That was funny, though. Come on. Okay, here we go. I don't know what 36 times 15 is. Do I? Yeah. Somebody hook up here. 36, I guess that's 360 plus 180. Huh? Yeah. Yeah, that's exactly what I just said. 360 plus 180, which is 540. WG, I could have did that. Then I got 15 times 5, so that's 75 root 7, plus 12 times 36 is 412? Is it? Shut your mouth over there. You guys are killing me. Come on, help. I need some help. 36 times 12. What? Oh, I was off by 20. So I have 75 plus 432. Is that what you said? 75 plus 432 is 507. Root 7s. And then 12 times 5 is 60. Times by 7 is 420. All over. On your test, it's not going to be this nasty. 36 times 36. I don't know my 36 times tables. 1296. Minus 7 times 25 is 175. Now, why did I skip the outer and inner terms of the FOIL distribution process? Because they're conjugates, and we don't care about them, damn it. Hey, whoa. You don't get a cuss. Do you have a 6-year degree beyond high school? Do you have a 6-year degree beyond high school yet? I do, so hence why I can cuss in my classroom. Mr. Atkinson can't even cuss in my classroom yet. He does. He has a 4-year, not 6-year yet. He's getting there though. So here we go. 540 plus 420 is 960 plus 507 root 7 all over 1121. There you go. Now, I made those up, so that's probably why they're nasty. Anyway, love you all. It might look different, but if you put it in your calculator, they'd be equivalent. Does that make sense? Okay. Last problem. That's awesome, but I'm going on. Okay, here we go now. Nuts. Look what you did. Come do your thing. I'm going to start setting it up. Oh. I don't know. I do, but I'm only here for 2 more months, and I don't care. I'm not going to use my money, and then I get one that's already freaking mounted into the wall. And my lights dim. I'm excited about my lights dimming. Yeah. I have. No, it's the same as this one right here without the office. So yeah, they don't have offices. I like the office too. Okay. Here we go. Last problem. Clap it out. All right. Let's go. Get excited. Okay. So notice, guys, I have a sum and I have a difference, right? So I'm going to write it out. Here we go. It's not too hard. Sine of x, cosine of pi force, minus sine of pi force, excuse me, it's a plus, sorry, cosine of x. Now I'm going to add, right below it, sine of x, cosine of pi force, minus sine of pi force, cosine of x. Now, if you guys will notice, what happens there? It cancels out, doesn't it? Right? These guys do at least. We're going to get rid of them. Here we go. Boop, 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 like that. So how many of these guys do we have? We have 2 sines of x's, cosines of pi force, and that should equal -1. Say again, brother. You're good, Trev? Okay, what is the cosine of pi force? It's 2 sine cosine pi force. Isn't this guy right here root 2 over 2? So what's 2 times root 2 over 2? Just root 2. So I have sine of x times root 2 equals -1. What does this look like now? Yesterday's homework, doesn't it? So this is saying, where does sine of x equal -1 over root 2, which is the same thing as -root 2 over 2, correct? Ladies and gentlemen, where does sine equal that? Say again, 5 pi force and 7 pi force, correct? And to be honest with you, the question asked for only answers between 0 and 2 pi. So I'm done. Yes, sir. No problem, Trevor. So what I did, Trevor, is notice I'm going to make this a little clearer over here, okay? I have 2 sine x times the root 2 over 2. Doesn't that 2 and that 2 get rid of each other? Does that make sense? And then I just brought out the root 2 out front instead of behind. And then I went from there. You with me? Okay, how do we do? We okay? Wasn't too bad, was it? Okay. Now, those are formulas you do need to memorize. Okay? But as you do the problems, the more it'll become ingrained in your brain, correct? Okay, here we go. 5-4. You're on page 404. Let's see what I want you to do. Hey, where's that book that I gave you? Will you hand me that book right there? Because I already had them highlighted. You guys are good people. I know some of your mamas and daddies tell me otherwise, but you're good people. Megan, your mom's called me like 5 times. See if I can help you out. No. What? Called your, why? That's funny. Who's your teacher? I could see Miss Burton doing that. She's like, you don't belong. You got 0? Hold on, Betsy. Whoa. I haven't heard that in a while, big fella. Yeah? So I've done it. Wow. Look at me. Changing generations. Last but not least, there they are. Now that looks like a lot, but it's really like about 20 problems. Okay? You guys are excellent people.